Yeah.
Question 1 is conservation momentum question. So P initial has to equal P final. Won't write the formulas out, but 4 times 8 for the initial momentum, and then going a different direction after the collision. Speed after the 2 left, so minus 2, well, 2, it's 8, and we don't know the velocity of B, and so V2 ends up to 5 meters second. Elastic or inelastic kinetic energy. So initial kinetic energy is half times 4, it's 8 squared, which is around 28 joules, and EK after the collision is half squared plus half m2 v2 squared, half 4 2 squared plus half 8 5 squared, which comes to 108 joules. Kinetic energy, initial kinetic energy does not equal final kinetic energy. Kinetic energy is not conserved, hence in elastic collision. Magnitude and direction of impulse on block B by block B on block A. So we just need to find the momentum, change of momentum of block A. So I equals change in momentum. So the final momentum was 4 times minus 2. Take that away from 4, the initial momentum, block A, which comes to negative 40. So magnitude is 40, and since negative, the direction is left. Students set up an experiment, mass of 4 kilograms and mass of 1 kilogram, initial at rest, calculate acceleration. So the force acting on it is mg, and we need to find the acceleration of m1. So we just use force from F equals ma, and the net force should be 1 times these 10 for gravitational, and it's 4 trying to find acceleration. Acceleration comes down to 2 meters per second squared. Calculate the magnitude of the tension of the string mass accelerate. So you just finding this. I mean, you could also find it here, but I think this is easier. So the tension would just equal ma before, and you found the acceleration before. Comes to up to 8 newtons. Circular force questions. At the lowest point, I'll draw the resultant force acting on. Resultant force is just the centripetal force. F. Calculate the magnitude of the force exerted on the track at the lowest point. Since it says the magnitude of the force exerted by the truck, you take all the forces on the truck, not just the resultant force. So centripetal force, and at that point the gravitation force is also acting on it. So m squared plus g. Mass is 2 kilograms. Radius is 4. And it's going at 6 meters per second. 2 times 6 squared. 4 plus 2, 10. This comes down to 38 newtons. Another model of the car. Show the forces acting on the car using solid lines and label each force. Show resultant force, dotted line. So we know the resultant force, F R. We know that gravity is acting on it. And we can draw normal force. Calculate the required angle. So let's find tan theta equals the resultant force, centripetal force, over the rotation force, which after you substitute everything in, it comes to tan equals v squared over g. I just used that from the start. Yeah, so equals tan v squared v, which is 17 degrees. Cover hits a ball and course. Calculate the maximum height. Expression for v squared equals u squared plus 2a. Yes, the highest point, we know that it's 0, and it's going at 40 is 40 for vertical sine 30 squared. It's 2. Acceleration is minus 10, and we don't know the distance, height. Then height comes to 20 meters. Again, the ball lands at a horizontal distance. The hitting off point is shown because of the vertical drop. So finding d. So we can find the time taken for it to travel the horizontal distance. So S equals ut is half t squared is 173 equals 40 cos 30. 20 has no acceleration, so that comes to 0. Oh. T is 5. You might want to keep like the full value in your calculator. And you find D. So again, we put the constant acceleration formula. Oops. So 40 sine 35 minus 10, 5 and it comes on to minus 25 meters. So from this point, it goes down further 25 meters. So D equals 25 meters. Mass of 2 kilograms is suspended from a spring. Spring constant is 50 for the distance of 80, 40. So which is gravitational potential and changing gravitational potential energy. H initially has at 0 there's no at 0.8 there's no gravitational potential energy. So 2 times 10 0.8 from here to here is 16 joules. Calculate the spring potential energy at its lowest point. Another simple question. Equals half kx squared. Half the spring constant is 50 times 0.8 squared. So again, probably didn't know how to do that. But for marks, calculate the speed of the mass at midpoint. So kinetic energy. So at the highest point, it's just gravitational potential. At the midpoint, we have kinetic energy, gravitational potential, and spring potential. 16, I won't bother writing the formulas out. To e squared plus 210, 0.4 is half 50. It's also 0.4. 16 equals v squared plus 8 plus 4. V equals 2 meters per second. The following graph shows the acceleration of the mass as it goes from the highest point to the lowest point. So, okay, just so the acceleration of the mass. So acceleration is given by the spring and also gravity. And you might think that acceleration is constant, but at the midpoint, force from the spring and gravitational force will be equal, and acceleration will be 0. So it can't be B or A, it's either C or D. And at the lowest point, and it's all directional. So at one point, all the acceleration will be up, and another point down. So it can't be D, it has to be C. Spacecraft is placed in orbit on Saturn, so that's Saturn stationary orbit in seconds. So Saturn stationary will be the same. The period of rotation of Saturn will be equal to the period of the spacecraft. It's T equals to 10. So 10 times 16 times 60 plus 15 times 60 is calculate the radius. It's Kepler's law question. T squared equals y squared gm, just r t squared gm over 4 y squared r. We got t before, 3000 squared. That's a constant. Mass of Saturn is 4.6 times 10 26 over 4 times pi squared, which comes to 1.08 times 10 to the power 8 meters. An astronaut in the spacecraft feel weightless. They feel that they experience apparent weightlessness, so they feel weightless. They not truly weightless as they experience gravitational force in free fall stars is now for so no contact forces acting on astronauts. We didn't do any of this. Electric power. First question is each side is 4 centimeters, 10 times B field is 2 times 10 to the power minus 3 Tesla. Yeah. Force on the side of EF, magnitude and direction. Okay, so F equals NBI. Oh, 10 is 10. B field is 2 times 10 to the minus 3. 4, 4 amps. Length is in meters, 0.04 meters, which is 3.2 times 10 to the minus 3 newtons. And direction is right hand palm rule, and you get up. Shows DC It's a common DC generator, uniform shaft is rotated by hand. It's DC, we get B. Shaft and column 2 complete rotations per second. Calculate the average voltage. So for 1/4 revolution, T comes to 0.125 seconds. You just use 2 complete revolutions per second, divide it down to 0.125 seconds. And the average voltage is, and change in time, got 10 turns times at 1/4 there won't be any flux into it. Yeah, other way around. 2 times 10 is 3, 0.125, which is 256 times 10 to the 6 volts, which is 0.256. To convert this DC generator into an AC generator. So since using a commutator for AC, they use slip rings. So place commutator with slip rings. Current direction be changed by slip rings. Every half turn. Providing an AC current. Okay. More diagrams. 14C, it's magnetic flux. 14T is EMF. Okay. So P to Q, there's no magnetic flux. That's entering, increases. I don't have the increases, it'll be straight. Increases, but at some point the whole square is inside. So there'll be no change in magnetic flux. Until it reaches the end. And then magnetic flux, it starts to decrease as it exits. And yeah. And EMF is the negative gradient of 14C at Q. And there's no change. And after it exits, it's a negative gradient, but since Lenz's law, yeah. Determine direction of current to the wall. It has the loop and as a field from X to Y or Y to X. Lenz's law. Okay. according to start lenses law. Induced current travels direction will create a magnetic flux that causes change in flux at induced current. There's a decrease in this is entering, right? Loop enters, so there is an increase in magnetic flux limits. The current must create flux upwards using right and pull. Current has to travel from X, Y through the volt. Turn the frequency, we can see the period is 40 milliseconds. Frequency is just F T 40 times 10 to the minus 2, which is 25 hertz. Determine the RMS voltage of the incoming high voltage. So this voltage is the output. I need to find input. It's 45. So the inputting, we peak. Output is 300. To find the input is the reason ratio. It's just multiplied by, so 1 to 45, so multiplied by 45, 1,000. VRMS is 1 over root 2 times E peak, 1 over root 2 times 1,000 is 955 volts. Right, just using the right hand, the grip rule, and you current is going this way. So you get force out from here in here. But I think you just do that as one continuous line, and you're going to get force line this way, and draw one more, and it's the same for. I'll just draw one. Yeah. Calculate the current in the wires. Pass it's operating correctly, so 2 volts clip and 4 volts. This is power formula P equals VI. You have the voltage, trying to find current, so P V. We have the power, which is 4 watts, and voltage is 2 amps. Calculate the voltage output from the power supply. You have the current now, so you can find the V drop across the transmission lines, which is IR, and 2 times the total resistance is 4, which is 8 volts. And at the globe it's 2 watts, so the V input is 8 V drop, so V globe, which is 8 plus 2, 10 minutes. Calculate the total power loss from the transmission. We have the current, we have the total resistance. P is I squared over R. I squared is 4 times 4, 16 watts. Calculate the current in the transmission lines in this situation. We have transformers. Again, we have to find only find current is using the globe values, which is 2 amps found before. And it's 1 to 10, and since it's the opposite and inverse for the current, its I lines is just 2 divided by 10 instead of multiplying. 0.2 amps. The power loss, which is P plus I squared or 0.2 squared times 4, 6 watts. It's called a real situation with this model could represent. Explain why the high transmission of its power losses you calculate in Allen and Becky. Okay, describe real situation. Transmitting power to long distances. Explain why the high transmission voltage is used. Power is maintained to transform since P equals VI, step up formula would discard since P loss equals I squared power loss is decreased with reduced current. Light and matter. Right. If you put a slide in there's a laser beam, and at the center there'll be a bright spot. So even at the center, even if it's double slits, it'll be a bright spot. So bright and the bright spot is at center at center there is a path difference of 0 wavelengths constructive interference occurs. Hence, right and separation B. So they're changing the distance. Use the fringe separation. I will be slits. They replace the original slits with the second pair of slits again, measure the distance between. And the distance over slit separation and the fringe separation is increasing, so D must go down to be less than increasing. Determine threshold frequency. Just look at the graph. You get 0 times 10, 14. That's Planck's constant is the gradient. So M, we'll take 2 points. I'll see this point. This point since they meet at the lines. There we go, H. And at frequency of 10, it's 2, 0. And we can just do 10 minus 5 times 10 to the power 14, which is 4 times 10, 15 electron volt seconds. So solid lines gets maximum kinetic energy if the frequency is intensive life, the frequency is doubled. Intensity of light of each frequency. So we know that intensity does not impact the ejected electron energy. So it's draw a line on top of the already drawn line. has a work, metal A is replaced with metal B, which has a work function 50% larger than that of metal A. Original light intensity was used. Energy. So the work function, you can find the work function for the original. You have the Planck constant now, so work function H0 4 times 15 times 5 times 10 to the power 14. That's right. Right. Comes to 4 times 10 to the power 15 times 5, 14. It's 2. And for work function of 1, so F come to 1 divided by 4 times 10 to the power 15. So 50% larger, so 3. It's going to be 7.5 times 10 to the power 14. So just draw one of those. You'll have to get the gradient right as well, but it's close to 7.5. Make sure the gradient's correct. If you can stop this value, then get same Planck constant and gradient. 19 information, calculate the energy from of n equals 2 and n equals 3 states. Oh, the n1 ground state. So the highest frequency value we have is 2.63. So that would likely be n equals 3 to, yeah. It's it says HF 2.63 times 16 times H is 109 electron volts. And the second highest which is going to be from here to here, Jeff, each times 2.22 times power 16, which is 92 electron volts. 2, and we don't really need that defined. N3 or N2. 9, 92. Different atom in the diagram with photons of frequency 7.25 observed. The diagram with the transition that could lead to this emission. So each times power 15 is 30 volts, 30 electron volts. Electron volts 120 minus 90 is 30. So third from here. Emissions. This is this expression. Electrons behave like waves. For the part electric effect, evidence is independence of ejected electrons from incident light intensity and the lack of time delay in electron emission. What evidence do we have that the electrons can behave like waves? Explain how this evidence supports a wave model of electrons. This is not about light, it's about electrons. You can't say the double slit experiment. You can try, but I think it's easy just to say electron diffraction. Electrons form diffraction happens when short through a slit of appropriate size diffraction is a wave. Use the model of quantized phase electrons at only certain energy levels are allowed. Okay. Electrons form standing waves. A nucleus only orbits circumference equal to a whole number of wavelengths allow for standing waves. Great orbits represent certain energy levels. Let's check out the correct program. Okay, this diagram. I'll try to draw this. Scuff drawing, but yeah. Electrons of mass 1.1 the Berkeley valence. Okay, so the Berkeley wavelength is HP. P is H over lambda. V comes down to H mass lambda. P H 6.63 times negative 34. Mass given as 1.1. Wavelength is 1 times 10 to the 11. 7.29 times 7 meters a second. Specialties. One key postulate. It's not postulate. You can tell fast and speed of light. That was not a postulate. It was speed of light is same no initial frames of reference. This laws of physics are the same in all initial frames of reference. The following statements reflect views held by Einstein proposed before Einstein proposed the special theory of relativity. Which one of these views is now still considered to be true? Observed speed of light in a medium depends on the speed of an observer relative to that medium. That's not true after Einstein. The speed of light in a region depends only on the values of electric magnetic properties of that region. It's true, but we'll keep going. Light is a wave comprising oscillating that cannot travel. Light cannot travel empty space. The initial frame of a medium in which light travels is traveling a special frame, and that frame speed of light. What special frames? Initial frame stuff. Soft Einstein. So it must be B. Star moving directly away from Earth at speed v emits light at a particular wavelength. Light is measured on Earth, and the wavelength is found to have increased. Wavelength is found to have increased. That's special relativity and length contraction. So it's not the speed of light changing. Yeah. Observed change of the wavelength is due to the length contraction resulting from the rotating with respect to the Earth, or is it the change of wavelength is not due to a change in speed of light, but a relative motion of the source and the observer? So the star is the thing that's moving. It will be about the wavelength relative to the motion of the star and the Earth. Yeah, see. Which one of the following observers will be able to measure a proper time using this clock? So it'll just be S. It's not seen on spacecraft S66. Observer E on Earth emits a short radio pulse. Spacecraft S66, which reflects it directly back to its observer. Time lapse for E between sending and receiving pulse is 20 meters, 20 milliseconds. According to E spacecraft, S66 is more than 3,000 kilometers away. And the pulse reached it. I'll probably just calculate how far that is. Equals 18. So it would be around 2,000 kilometers. I mean, equals VT. And so only more. According to E, the pulse took longer to reach spacecraft than it did to return from it. S66 to no, pulse took longer to reach than it did to return from it. Success. No, it's light. The 20 meters second interval measured by E is not proper time because the radio pulse traveled away and back. That shouldn't affect it. The spacecraft being sent and being received back by E is greater than 2 meters a second. So S66 is moving at high speed. So it'll T proper time is 20, and this will be a value greater than 1. So the time seen by X66 would be higher than the proper time, T. The clock on spacecraft S66 has an indicator showing time intervals of 0.1 seconds. Navigator of spacecraft T50 observes the duration of the time intervals is 0.15. So proper time is speed. Proper time 0.1. T0. So 5. Oops. Okay. To get 1 minus v squared, c squared is divided by 2, and the reciprocal of it 0.8696. So I'll just keep the whole value in your calculator. B squared is by itself. And 0.244 V is 0.5 C D. The designated landing area of the comet has length 500 meters, and the comet's frame and is parallel to the spacecraft. The length of the landing area as measured by the instrument C. So, proper length is 500 meters. Proper length 500, and they give us the Lorentz factor. It's 333. See, it's 2 main velocity as the comet. They'll be in this after the same velocity, the same frame reference, and the probe will be able to measure proper time. The other ones are like obviously wrong, and looking at different speeds. No, pulse won't be momentary station. So 9 a nucleus in an excited state emits a gamma ray of energy 1.8 times 10 to the power negative 13 joules as it decays to its ground state. The initial mass is mi, E equals mc squared, and then mass comes to 2 times 10 to minus 30, and it's emitting this, so it's losing this much mass. So it'll be the initial mass minus particle of rest mass is accelerated from 0.6 relative to Earth's frame. These will take a lot of time to do formulas, but we always know that the work done is equal to the kinetic energy of the particle, so it's P. The rest energy will increase. According to Einstein's theory of relativity, the rest energy of mc squared for a particle of rest mass m and the kinetic energy of the particle is this. Which one of the energy curves best gives a relationship with kinetic energy to the rest energy? Function of speed v. Kinetic energy keeps increasing while rest energy does not change. So ek, there's no value for zero speed, so it can't be a, and it can't be c. These saying that kinetic energy does not keep increasing. It's come to a constant. It can't be d. It has to be b. And so.
Thank you.
Thank you.